Hello there, Physically Debunked here, back again to talk some more about the Kalam Cosmological argument. In the last video we discussed the first premise of the argument, so unsurprisingly we're now going to take a look at the second one. The second premise of the cosmological argument simply states that the universe began to exist. This premise, combined with the first one, yields a deductive argument whose conclusion that the universe must have had a cause certainly follows if both the premises are true. If either of the premises are false, however, then so is the conclusion. We've already looked at the first premise and I wasn't particularly convinced by it. But let's forget about that for now. Let's assume that the first premise is true. Then the truth of the conclusion of this argument depends solely on the truth of this second premise. So let's take a detailed look at it. Is it plausible that the universe began to exist? As with the first premise, when taken at face value, the second premise does seem pretty solid. In school, aren't we all taught that the universe did begin to exist? Aren't we told that our universe began to exist 14 billion years ago in an event called the Big Bang? We're certainly told that these are the findings of our best science. So if science is telling us that the universe began to exist, then shouldn't we take this as convincing evidence in favour of the second premise? When presented to popular audiences, the Big Bang is described as the event at which our universe began to exist. But this isn't strictly true. The Big Bang Theory does not purport to describe the ultimate beginning of physical reality. A much better characterization of the Big Bang Theory is that it's about the beginning of our universe as we know it. It's clearer if we put things in a historical context. Before the Big Bang Theory, physicists largely assumed that the universe had always existed in precisely the way we find it today. They believed that there had always been stars, that there had always been planets, and that there had always been galaxies. While the objects within the universe may change and transform quite drastically over time, the universe as a whole was seen as static, in a steady state. What was so revolutionary about the Big Bang Theory was not that it proposed that the universe began to exist. Rather, it was that it proposed that the universe had not always been in the state in which we find it today. If you rewound the clock back 14 billion years, then the universe would look completely different to how it does today. Since its inception, the Big Bang Theory has been exceptionally well confirmed by observational evidence. It is without a doubt now a scientific fact that our universe has been expanding for 14 billion years and that all of the stars, planets and galaxies we see were formed during that time. And that's really what the Big Bang Theory describes. It's not a theory about the origin of our universe. Rather, it's a theory about how the universe as we see it today was formed from the very early universe. If you look at diagrams such as this one, you can see that the Big Bang Theory works from very early times, but at some stage we just have a load of question marks. Beyond a certain point in the past, we don't have any idea what happens. Now you might ask about the Big Bang Singularity. Don't physicists talk about the Big Bang Singularity, which is supposed to be the t=0 state of our universe, the initial point of infinite density that started expanding? Yes. Physicists may use the term Big Bang Singularity, but this doesn't mean that the Big Bang Singularity is something that we think is actually real. The way physicists talk about the singularity does make it sound as if it's something that's physically real. It's not. A singularity is not a physical thing. Singularities don't exist. What singularities are points in our mathematical descriptions where physical quantities blow up and no longer become meaningful. The centre of a black hole, for example, is a singularity because in general relativity, the mathematics blows up and becomes infinite at that point. These infinities are not physical. When we see a singularity appear in a theory, we don't conclude that those singularities exist in nature. What we conclude is that the theory we're using breaks down in that environment. General relativity is very good at describing how things behave in most of the universe, but in extreme environments, like inside a black hole or close to the Big Bang, singularities appear and we recognise that our theory breaks down. What we need to actually understand these cases is an improved theory of physics. In the case of the Big Bang, we'll have to wait for a quantum theory of gravity in order to be able to say anything meaningful about what happens close to the Big Bang. To summarise what I've just said, it would be controversial to say that the scientific evidence supports the statement that the universe began to exist. What science does tell us is that our universe hasn't always existed in the state in which we find it today, and that 14 billion years ago, conditions were so extreme that our current theories break down there. Now, it could be true that the Big Bang event was an actual beginning of the universe, but this is just a possibility, not a prediction of our current science. Our current science simply says nothing about what happens close to the Big Bang, and so any theory concerning what happens there is currently just speculation. A big clue that the Big Bang theory doesn't purport to be the beginning of the universe's existence is the fact that lots of research is done into theories which extend beyond the Big Bang. Cyclic universes, symmetric universes, and all kinds of multiverse are serious proposals to extend further than the Big Bang, because we realise that the Big Bang is not necessarily the beginning of our universe's existence. Before moving on from scientific evidence, I do want to make one comment on a particular theorem that some apologists cite as proving the second premise. This theorem is the BGV theorem, which states that inflationary spacetimes are not past complete. What this theorem states is that if you have an expanding spacetime like our universe, then at some point in the universe's past, you'll hit a boundary, beyond which the geodesics, rather the paths particles move along, cannot be continued. I've already discussed this theorem at length in another video, so all I'll say here is that it's simply wrong to interpret this theorem as saying that the universe began to exist. A quote from the original paper demonstrates this. What can lie beyond this boundary? Several possibilities have been discussed. Inflation alone is not sufficient to provide a complete description of the universe, and some new physics is necessary in order to determine the correct conditions at the boundary. In other words, what the BGV theorem tells us is that new physics, such as the theory of quantum gravity, is needed to understand what goes on at and beyond this boundary. It is not saying that this boundary is the beginning of existence of the universe. That's it for the scientific evidence for the second premise, but there are more arguments that can be made in favour of it, coming now from a philosophical angle. One approach is to argue that the existence of actual infinities is impossible. The argument goes, if the universe didn't have a beginning, then it must have existed for an infinite amount of time. But the existence of actual infinities is impossible, therefore the universe must have had a beginning. I disagree with both of the premises of this argument. With regard to the first premise, it is possible to have a universe in which time forms a closed loop. Instead of a time line, you have a time circle. And so, just as a circle has no beginning, the universe also doesn't have a beginning. This is very unlikely to be the case for our universe, but it is at least a counterexample to the first premise. You could reformulate the first premise then to exclude these kinds of universe, but a possible counterexample still exists. There are certain speculative theories of quantum gravity that seek to deconstruct time. In these theories, time is no longer a fundamental entity. It's something that emerges from the dynamics of what does fundamentally make up the universe. If something like this were true, then as you got close to the Big Bang, time would no longer be a meaningful concept. You'd enter a regime in which time no longer existed, but the universe still did. In a model like this, the universe can fail to have a beginning, but there isn't an infinite amount of time either, since time itself breaks down. This is speculative, of course, but the interest in trying to forge theories of physics where time is no longer fundamental should lead to caution when considering the naive assumption that a beginningless universe must have existed for an infinite amount of time. In favour of the second premise, that actual infinities cannot exist, apologists offer a range of apparent paradoxes, which demonstrate how bizarre an actual infinity would be if it existed in the universe. Unfortunately, we don't have time in this video to go into these interesting paradoxes. I suggest that you look them up and think to yourself whether they are genuine paradoxes. My own opinion is that they're not. Although scenarios like Hilbert's Hotel are bizarre and counterintuitive, I don't think they demonstrate impossibility of actual infinities. There's an additional argument in favour of the second premise which argues that time cannot extend infinitely far in the past because an infinite amount of time cannot occur. Apologists argue that because you can't get an infinite quantity by adding successive finite quantities, an infinite amount of time cannot have passed, because time passes by successive addition of times. My answer to this is simply to point out that I, and many others, don't think that time passes by successive addition, so I don't need to consider this argument any further. Finally, I want to talk about something which I think is actually a strong reason against the second premise. This reason is a combination of philosophy and physics and concerns the nature of time itself. In the philosophy of time, you have two main camps, A theorists and B theorists. For our discussion, we can just consider two examples. One, an example of an A theory of time, the other of a B theory. Presentism is an example of an A theory of time, and is the belief that only the present really exists, and that this present time flows from the past to the future. In broad terms, presentism claims that the way we personally experience time is the way that time really is. On the other hand, we have the block theory, which is a B theory of time. This theory instead claims that all times are equally real, and that the universe is really just one big four-dimensional shape, with time being a particular direction along it. Now, if the B theory of time is correct, then the second premise, that the universe began to exist, is false. If you don't believe me, ask William Lane Craig, who said, on a tenseless theory of time, that is, a B theory, the universe does not in fact come into being or become actual at the Big Bang. It just exists tenselessly as a four-dimensional space-time block that is finitely extended in the earlier than direction. If time is tenseless, then the universe never really comes into being, and therefore the quest for a cause of its coming into being is misconceived. So, if something like the block theory of time is true, then the second premise fails immediately, since the universe, as a four-dimensional block, always exists. It doesn't have a beginning to its existence. Given that this is the case, it's not surprising at all that apologists like Craig firmly support A theories of time like presentism. But here's the thing, physics overwhelmingly supports B theories of time. A theories of time argue that tense is real, and so they argue that there's something special about the present. Presentists, for example, believe that the present time is the only time that exists. What we've learned from the physics of relativity, however, which is our best theory of how time works, is that there isn't a defined present. In relativity, simultaneity is relative, which means that different people can disagree over when an event occurred. There simply isn't a global time for the universe. There's no universal present. Now, it is technically possible to define a present in special relativity, but this is imposing extra structure onto the theory, and any particular choice of how to define the present is no different to any other. It's completely arbitrary. The problem is even worse in general relativity though, since there are certain spacetimes, like Gödel universes, where it's entirely impossible to define a present. You couldn't add a definition of a present even if you wanted to. Now, despite these arguments, there are still philosophers out there who support the A theory of time, and it's true that the A theory hasn't been conclusively ruled out. But let's summarise the situation so far. Our best physical theory of time is general relativity, and taken on its own, it is a B theory of time. You could even say that general relativity is logically incompatible with an A theory of time, since you can construct spacetimes in general relativity in which it's impossible to define a present. To me, this is strong evidence in favour of the B theory of time, and if the B theory of time is correct, then the second premise is immediately false. So there we go. Those are what I believe are all the key points surrounding the discussion of whether the second premise of the cosmological argument is true or not. What's my verdict on it? I think that this premise is extremely weak, largely because I'm personally convinced that the A theory of time is incorrect, and if that's the case, then the second premise is strictly false. If I ignore my bias toward B theories, then I'd say that purely based on the other arguments, the premise is so-so. It could be true. Our universe could well have begun at the Big Bang. That is certainly a plausible thing to believe. But there are alternatives out there, and we simply don't yet have a theory of physics that can tell us what's going on close to the Big Bang. But if I consider everything, including the A theory, B theory debate, then I've got to give this premise a rating of 1 out of 10. To be honest, it feels really harsh to give it a rating that low, because it seems quite plausible that our universe only extends finitely far in the past. But the fact is that finite extension in the past isn't sufficient for there to be a beginning of its existence. Even if the Big Bang was the first moment of time in the universe, if the B theory of time is correct, then it would still be incorrect to say that the universe began to exist. Since I think that the B theory of time is far more supported than the A theory, I have to strike this premise off as being very, very implausible. Thank you very much for watching, and I hope you enjoyed. Stay tuned for more analysis of the most common arguments for God's existence.